Welcome to lesson 3.5. 3.5 is on using a compass. Our objective is to review compass skills and explore angles formed by intersecting lines. So let's get started. One thing I want to point out on my compass here on the first page is what is this point called? And that point is actually called our anchor. It kind of anchors things in place so that our pencil can make our marks to help us draw line segments and to form angles. So let's get started. Oh, we need to reset our thing here. So in math, there are some things we need to talk about. And one thing we need to talk about is our words. We have diameter, circumference, about 3 times is our rule here. It says about 3 times rule. And the radius. So here are our definitions. The distance around a circle. Hopefully you all have some recollection of what that might mean. The circumference of a circle is about 3 times its diameter. The center of a circle has its endpoints in the circle, and any line segment from the center of the circle to any point on the circle. So now I drew a little diagram over here, if you can see this little guy over here. Now what I was trying to show here, and I'm going to draw a circle here. It's not going to be great, but it's a circle, somewhat of a circle. So here's our radius. Anytime we draw our radius always starts from the center and goes to the outside of the circle. It can go anywhere, but it starts from the center. The difference is that is our diameter. Our diameter always goes through the circle, again, through the center to any endpoint, again. But that's the difference between the two. So let's take a look. The distance around a circle. I hope you all know that that is your circumference of a circle, the distance around it. And hopefully this next one kind of gives us the answer. The circumference of a circle is about 3 times, so that's about the 3 times rule. Now, diameter versus radius, and I know we have talked about this a little bit. The center of the circle has its endpoints in the circle, or the circle to any point. Oops, I gotta go back here. Any line segment from the center of the circle to any points. This means it starts in the center and goes to the outside. This one goes through the center. So I know that when it goes through the center, it's my diameter. And I know when I start in my center and I go outward, I know it's my radius. So that's a good way to start though, so that we are practicing our vocab words. So let's check. And we did great. So it says, draw the largest and smallest circle you can draw with your compass. What is the radius of the largest circle? Again, radius meaning from the center out to any point on the circle. But I want you to think about it. We're not going to do this. You're not going to draw them right now. But how would you draw the largest and the smallest? I would like you to write that down and bring that into class tomorrow so we can talk about what would that look like and how do we do that. Good to think about. Okay, let's move on. Okay, so now we are going to talk about copying a line segment. And again, I want to talk about the anchor. So it says use your compass and straight edge to copy the line segment AB. Do not measure the line segment with a ruler. Label the end points of the new line segment as points M and N. Line segment MN should be the same length as line segment AB. So if I start here with my compass, I always put my anchor right here, and this becomes my anchor. And your anchor, again, is the metal pointy part. Now, it always goes on to this part right here on A, okay? And then what I do is I take my pencil and I set it here and I stretch it to here. And that's how I measure. I set my anchor on my paper right here, okay? I go down and I swing with my pencil. Then, without measuring, I should be able to draw a line from my point to my arc, and that will give me my line segment. So again, something that we have to practice in class to get familiar with. And when you have a compass that you're using and it's in front of you, it makes a lot more sense. So number 2 says 3 line segments are shown below. It says use your compass and straight edge. Construct one line segment that is as long as the 3 segments joined together end to end. Label the 2 endpoints of the long line segment X and Y. So one thing you're going to do to start with this, again, having your compass in class makes it a lot easier to practice and to work with it. But one trick with this is, and something that I don't think many of us think about, is that if you draw a line that's longer than all three, that will help you a little bit because it will give you a vision and somewhere to start. Again, you're going to start your anchor on the very end, and again, you measure from A to B. Start with your anchor on the very starting point and swing your arc. Put your anchor on that arc, kind of like over here, like I'm showing you right on this thing. Whoops. Right here, you put your anchor here again. And then you go down and you'd swing again. You'd swing your pencil down here where it measures. And then you put your arc there and so on. Again, something for us to practice in class when we have our compasses in front of us. Gives us a little more hands-on. But something to think about, because sometimes when you draw a longer line, it gives you a good visual of how long your line will probably be, and not as long as the line you've already drawn. Okay, so let's move on. So it says copying line segments and finding lengths. One thing that we are going to practice is we're going to practice measuring and using our geometry templates, so our blue templates. And we're going to find the length of the longer side of a rectangle on our geometry template. And so what they did is it says open the compass to the length of the longer side. They have the anchor. So the little anchor right here, up there. And then they have the pencil down here. And it says don't change the opening of the compass. Hold the compass against the ruler, and then it measures about 1 inch. Now, one thing to keep in mind is that this little guy at the top, it's going to come in really handy, because if we move either side when we're trying to draw lines, we change the measurement. That's why we have to get really used to using the top little knob I call it, to swing our lines, because anytime we touch the sides, we change our measurement. So we are going to practice this in class, and you'll become familiar with how to use it again and using our template. So our last part of this lesson is on adjacent and vertical angles. And I want to start here. I have kind of some drawings made here, and I want to kind of erase my drawings here, just so I can give you an idea. Angles that are next to each other are called adjacent angles. Adjacent angles have the same vertex and a common side. So, for instance, when I look here at this, and I have angle A, B, and C, and I have angle C, B, E, they share this side right here. They are not directly across from each other. They share a common side. ABC, CB, E. So BC or CB is that common side that they share. Now, angles ABD and CBE are vertical angles. They are vertical because they are directly across from each other. Here and here, or here and here. That is what you call vertical angle. So it says name another pair of vertical. Well, I would name, and I know I have it messed up, A, B, C, and D, B, E, because they are vertical or directly across from each other. So again, a good way to do this, and I'll kind of erase so you can see that. Angles ABC and CBE are adjacent. Name two other pairs. So they have A, B, and C, and they have CBE, which is what I talked about. So what's another side that we could do? EBD and DBA or ABD, again, sharing the side. So ABD, and then DB or BD is the side that they share that causes them to be adjacent angles. So something to just think about as you're working with adjacent angles. So let's move down a little bit so we can kind of talk about this a little bit more. So now on here, and I need to erase again, I apologize, I kind of draw as I'm trying to work on my lessons ahead of time. So it says two lines at the right intersect to form 4 angles, and we can see the 4 angles, 1, 2, 3, and 4. One angle has been measured. Use your full circle protractor to measure the other 3 angles and record your measurements. Now it says on a blank sheet of paper, draw 2 lines that intersect. Measure the 4 angles. Record the measures on your drawing. We'll work on something like that in class, so you do not have to draw that. But I do want you to think about, what do I notice here? If I have an angle here that is 60 degrees, okay, and it is vertical of this angle, what do I think my measurement over here will be? And if I measure this angle that is adjacent here, what do I think these two angles will measure? So please think about what I know about vertical. And this, they've given me a measurement. Do I know what this measurement is? Do I need to measure? So please write down what you think and what do you notice about the measures of pairs of vertical angles? And what do you notice about the measures of adjacent angles? Because that's kind of an interesting thing to think about. So write down what you think your answers might be to that. Okay, so let's go back and review and see if we've done what we were supposed to do. So it says using a compass, we were going to review compass skills and explore angles formed by intersecting lines. And we did that. So in class, we will be working on measuring, drawing line segments, measuring angles, vertical and adjacent, and how do we know what their measures are going to be, and practicing what a vertical and adjacent angle are. Great work. Please make sure you complete the quiz.